NCERT exercise question number 10.16 to 10.20 for chapter biomolecules. The very first question today: how do we explain amphoteric behavior of amino acids? Amphoteric means any substance which has got acidic as well as the basic character, or which react with acid base both. So amino acid, they contain two types of functional group. First is acidic group, which is carboxyl group or carboxylic acid group, and basic group, which is amino group in the same molecule. And in aqueous solution, that is when we make solution of this amino acid in water, the carboxyl group loses a proton, that is H plus ion, and amino group accept this proton or H plus ion. So we get a dipolar ion known as Zwitter ion. Dipolar ion means ion having two poles in the form of positive and negative charge. Now in Zwitter ion form, amino acids show amphoteric behavior, as these amino acids, they can react with both acids as well as bases. Okay, so here this is amino acid, and here this is the carboxylic acid group or carboxyl group, and this is amino group. So this H plus ion from carboxyl group, it can move to the amino group, and we get this Zwitter ion structure where we are having two poles. This is the negative end and this is the positive end. And because of these two types of charges, this Zwitter ion can react with acid as well as bases. So this is amphoteric behavior of amino acids. Second question: what are enzymes? As we know, we can speed up any chemical reaction with the help of catalyst. In the same manner, in a living system, we can speed up any reaction with the help of enzymes. So enzymes are called as biological catalyst, as they speed up any biological or biochemical reaction in a living system. So but chemically, if we see their structure, they are basically globular protein, and these proteins in the form of enzymes, they are very specific for a particular reaction. That is, for a particular reaction we have to use a particular type of enzyme, and they are also specific for substrate. That is, different substrate, they undergo a different reaction with the help of different type of enzymes. And as they are needed in small quantity, and they are also workable at normal room temperature and normal pH, that is neutral pH, near to neutral, and at 1 atmospheric pressure. Now these compounds, they can be named either after the name of compound on with which they react, or on the basis of the reaction where they are used. Like for example, maltose is malt sugar, it is a dimer, so we will get 2 molecules of glucose from maltose after hydrolysis with the help of enzyme called as maltase. Name of any enzyme end in ase. Second example, here if we want to bring about simultaneous oxidation and reduction reaction, that is basically for the electron transfer reaction, so their enzymes used are oxidoreductase. Again, name is ending in ase. Next, what is the effect of denaturation on the structure of protein? We know the proteins have their native form, that is, they have a specific 3D structure. According to that, they have their biological activity. And when we have denaturation, secondary or tertiary structure of protein, which is responsible for their biological activity, is destroyed. Only we get in the end what? Primary structure, that is polypeptide chain. And due to this denaturation, the globular protein, which is soluble in water, is converted to fibrous protein, which is insoluble in water. So therefore nature of protein changes, and their biological activity is also lost. As again, I am repeating that biological activity is because of the 3D structure. If it is lost, activity is also lost. For example, when we boil egg, the protein present in egg, it undergo coagulation, and this coagulated protein cannot show any biological activity because of the loss of native form. So this is all about the effect of denaturation. Next question. How are vitamins classified? Name the vitamin responsible for coagulation of blood or clotting of blood. So first, classification of vitamins. Vitamins are classified into two groups depending upon their solubility in water or fat. So if, as we know, if your vitamin is soluble in water, it is called as water soluble vitamin, and such vitamins are very readily excreted in urine, and therefore they cannot be stored. Therefore we should have them in regularly in our diet. And this is here the examples are vitamin B complex, which is basically a group of different vitamin like B1, B2, B6 and B12, and vitamin C. All these water soluble vitamin, they cannot be stored, but exception is B12. B12 can be stored in our body for a long period of time. Next is fat soluble vitamins. So those vitamins which are soluble either into solid fat or oils, they are the fat soluble, and examples are vitamin A, D, E and K. And as the name suggests, we should take these vitamins along with the fat so that they are readily absorbed by our body. These are stored in liver and adipose tissue. Second part of the question, name the vitamin responsible for coagulation of blood. So vitamin K is responsible for coagulation of blood or clotting of blood, or we call it as blood clotting factor. Last question, why are vitamin A and C essential for us, and give their important sources. So first, vitamin A. Vitamin A is important for normal vision, and if we have deficiency of this vitamin, we can have disease like xerophthalmia, which is hardening of cornea of eye, or night blindness. And the sources are carrot, fish liver oil, butter and milk. Vitamin C is required for growth and repair of all type of body tissues, and also to have a good immune system. And if we have deficiency of vitamin C, we can have disease like scurvy, that is bleeding of gum, or pyorrhea, that is loosening and bleeding of teeth. And the sources are amla, that is Indian gooseberry, and citrus fruits like orange or lemon, and green leafy vegetable. So this is all for today. We'll continue this chapter in the next video. Thank you.